I thought I'd start by showing you your data from this morning. Thanks very much. Just to remind you, these were the two versions of the decision that you were asked to make, and each of you saw one of those two decisions. So here are your data and the data from Tversky and Kahneman. So on the left is Tversky and Kahneman's data. I label these things based on what Group A was going to do, right? So this is the version where Group 200 were going to die in the Group A configuration. In the other version, right, 200 were going to be saved, and this one 400 were going to die. And again, there's a tendency to risk in the face of negative outcomes, a tendency to prefer positive outcomes. And you see that generally in this audience, you like risk more generally than in the other audience. I would say this little red dot here, there were two people who didn't like either option. They drew a letter C and circled that. So they didn't actually specify what that would be, but they had a third option in mind. Or they were messing with me, one or the other, I'm not sure. Anyway, just to kind of give you, and that's something to talk about over lunch. Okay, so I've decided there's a problem. So this last problem is a division problem. And for those of you who saw me give a talk here 3 years ago, this is a little snippet from that talk, but it's germane to what Scott and I are trying to do today, because it's something that many of us have experienced. So I'm going to ask you all in your head to solve for x in that equation. So I'll wait for a few seconds while you do that. And then I'd like someone to raise your hand and volunteer an answer. Okay, now there's like 300 people in here, and like 5 people raise their hands. Now, you know, I often give a talk. In fact, I've been doing it every year for about the past 16 years. The opening talk for new faculty that we hire at the University of Texas in Austin in August. In a few months, I'll give this talk again. And I put up this slide, and I ask the same question of that audience. Now, we probably hire 120 new faculty every year. And these are some people just out of a postdoc, and some have come from other universities, those kind of things. And I put this slide up, and I asked that question, and 5 people raised their hand, and they're all in the math department. And actually, when I put this slide up several years ago, Tom Check was in the audience, and he told me at the reception afterwards, you put up that slide, and he thought, I'm not raising my hand. It's Tom Check. I mean, I think your reputation's intact now. But the thing that I asked my colleagues to think about is, why the hell aren't you raising your hand? And of course, the answer is the same reason your students don't raise your hand when you ask a question. Because what if I get it wrong? You know, what if it's a trick? What if it's not as obvious as I think it is, right? And you all know, I mean, even being bright, accomplished adults, if you raised your hand and I called on you, and you said the answer is 3/8, which is not, and I said, well, actually, it's not 3/8, that would be the defining event of your week. You'd be home at night on Sunday night staring at the ceiling in the dark going, God, why'd I raise my hand on Saturday? That's intensely perverse, right? Now, I will ask someone who did volunteer to answer the question. Yes, ma'am, would you tell me what the answer is there? 1.5. So could you tell me how you got to that from there? Uh-huh. Yeah, all right. So you did it in a completely conceptual way, right? You just thought about a thing that's 3/4 and a half thing fitting in there. Yeah. You did that, right? Yeah. So you did this too. Many people, this is the universal symbol for that equation, is to do this. So the answer is you invert the divisor. That's that term in the equation called the divisor, by the way, and you multiply straight across. You get 6/4. You reduce the fraction. You get 1.5. Now the question I ask people after they give that answer is, they say, well, why do you invert the divisor? I mean, why do you do that? Yeah, and you're right. And usually I get that's what we were told, or just crickets, you know. Now, the thing that's interesting about this is that the only thing that's interesting about that equation is the rationale for inverting the divisor. The most interesting answer, and honest answer I got from that, I asked a group of 5th graders once, I'd driven a problem like that on the board, and I said to the kids, well, why do you invert the divisor? And this kid in the front row raised his hand and said, because if you don't, you get it wrong. What better rationale does one need for behavior than that? So But here's my point about this problem in the context of what Scott and I are doing right now. If the goal of an institution is to get rooms full of disparate people to get the right answer to a problem, then one effective way to do that is to create problems like that on pages of paper with different numbers in them and teach everybody to go invert and multiply, invert and multiply, invert and multiply, invert and multiply. And you will get rooms full of people all getting the right answer, most of whom have no idea what they're doing. Now, the whole point about learning, in most circumstances, now if you're teaching somebody to work on an assembly line and do a widget, well, when this piece comes, put that piece there, okay, that's something that doesn't require a lot of generalizing. But most of what we say we're doing in universities and online education, those kinds of things, we're not teaching you to do a particular thing. We're teaching you to learn about something that will allow you to generalize what you know to circumstances that you may not anticipate and that we may not anticipate you're encountering in the future. Well, you don't do it like that. You don't do it by invert and multiply. So the takeaway from this is to chew on over lunch, and you can kind of say, well, what is the rationale for doing that? You can figure that out over lunch too. But the idea is how it's possible to teach people in a way that gets them to come to the correct answer, however that answer is configured, without really understanding what happened to get them there. Now, that is a failure in education at all levels of instruction, from kindergarten through higher education, actually. And it's something that I hope you'll enjoy talking about over lunch. So thank you for your attention, and we have a next speaker.